This video playlist is about an application of eigenvalues and eigenvectors for face recognition. We start with a database of facial photos like this. What we have to do with this, we will process all these photos somehow to extract some information relevant for face recognition, and then when we are shown a new photo, then we should be able to recognize this from just the extracted info. That's of course the high level description. We are about to see the details. This project involves image processing, that is, working numerically with digital images. So we should first learn about how to convert images to numbers and also numbers back to images. Here is a digital gray level image, this little tiny one. Now if we zoom in a lot, it looks like this. You can see that the image is made up of some tiles, these little square elements. Each tile is of a single flat color. Each tile is called a pixel, an abbreviation of picture element. Thus, the entire image is a rectangular array or matrix of tiles. Here we have 30 rows and 20 columns. So we say that the image has size 20 cross 30. Notice that the number of columns, the number of columns is mentioned first, number of rows comes next, which is just the opposite of the convention used for matrices. Each pixel is of a single flat shade of gray. Now typically the level of grayness is expressed in a scale which goes from 0 to 255. Thus, this 20 by 30 gray level image is basically a 30 by 20 matrix of numbers, each in the range 0 to 255. Well, now that we understand the numerical nature of digital photos, it is time to learn about how these numbers are stored in an image file. The entire process of converting an image to a file occurs in two stages inside the camera. In the first stage, a real image is digitized, that is, converted to a matrix of numbers. In the second stage, these numbers, along with sundry other informations like image size, timestamp, location, etc., are encoded as a sequence of bytes and dumped into a file. The second stage may be done in different ways. Each way is called an image format. Some popular image formats are JPG, PNG, and TIFF. There are some other things like TIFF and etc. The resulting file is usually given an appropriate extension to indicate the format to a human user like .png or .jpg, etc. But this is just a hint. If someone changes the name of a PNG file from abc.png to abc.jpg, the format used inside still remains PNG. Now we shall see how to invert the second stage. That is, given an image file, how do we extract the pixel values? Okay, here I am going to show you a file, a JPEG file, test.jpg, and this is that little image that you can see. Maybe I will zoom in a little bit. Of course, I am not increasing the size of the actual image, I am just zooming in, and I will show you the size. It is width 20 pixels and height is 30 pixels. And I also have the PNG version of the same file. I will show you both. Again, it has the same size, 20 pixels wide and 30 pixels high. Now I want to extract the pixel values using R. So I will do library JPEG and then x equal to read JPEG, and then I will specify the name inside quotes. I need to put the dot, yeah. And let me see, this is the dimension, it is 30 by 20, and I can see that the x values are all lying between 0 to 1. Now I will try to do the same thing with the PNG image. For that I will need to use the PNG library. I first of course installed it, and then I will try to load it in a different variable. It is read PNG. Again this file test PNG, and this time I will try to see the thing. It is again 30 by 20, and now you can see that the values are of course the same things, but they are printed in this way, just going very fast from the screen, so you cannot see all the things. So this is the entire thing. This is the 30 by 20 data. Okay, so that's how you extract the values from a file. You might try to be naughty and try to do this, load this into that, and then you will get an error because file is not in PNG format. So read PNG is for PNG and read JPEG is for JPEG.